Who would have thought that a bright pink lake could truly exist, not an edit or a camera effect? Lake Hillier in Australia holds a rare uniqueness. Its water remains pink even when transferred into a bottle. This natural phenomenon has sparked scientists' curiosity and left the world in awe. Lake Hurl is located in a remote area of the southern region of the Australian continent, specifically on Middo Island, which is part of the Rache Archipelago. This archipelago lies off the southern coast of Western Australia and falls within the administrative territory of Western Australia. Its separation from the mainland places Lake Hurrell in a relatively isolated natural environment with minimal human activity. Geographically, Lake Hurrell is situated not far from the coastline of the Southern Ocean. The lake is separated from the sea by a narrow strip of sandy land and coastal vegetation, yet it remains under the influence of a maritime climate. This position gives the lake climatic characteristics shaped by sea winds, moderate to warm temperatures, and relatively high evaporation rates throughout the year. Middo Island, where Lake Hurrell is located, is the largest island in the Recherche Archipelago and is dominated by natural landscapes such as sandy beaches and granite rock formations. Lake Hurrell lies in the central part of the island, surrounded by natural vegetation that functions as an ecological buffer zone. The presence of this vegetation limits the direct inflow of large amounts of fresh water, resulting in relatively stable and distinctive water conditions within the lake. From a hydrological perspective, the absence of a direct outlet to the sea classifies Lake Hurrell as a closed lake. The lake's water primarily originates from rainfall and seawater seep through the surrounding sandy soils. The combination of its geographic proximity to the sea and its high isolation plays a crucial role in shaping the physical and chemical characteristics of the lake's waters. The difficult accessibility of Lake Hurrell has helped protect it from anthropogenic pressures such as pollution and development. Access to the lake is generally limited to air or sea routes and requires special permits, as the area is designated as a nature conservation zone. These conditions make Lake Hurrell an important subject for studies in physical geography and the ecology of extreme aquatic environments. Thus, the remote geographic location of Lake Hurrell, its proximity to the sea, and its setting on a natural island are the main factors influencing its environmental characteristics. This position not only determines the lake's climatic and hydrological conditions, but also plays a significant role in the formation of Lake Hurrell's uniqueness as one of the most well-known pink lakes in the world. The pink color observed in Lake Hurrell is a natural phenomenon closely related to the interaction of physical, chemical, and biological factors within the aquatic environment. This color is not caused merely by the reflection of light, but rather by the presence of microscopic organisms and specific environmental conditions that support their growth. Scientifically, pink-colored lakes have been documented in many parts of the world and are generally associated with the level of salinity and the biological composition of the lake water. From a biological perspective, the pink color of Lake Hurrell is caused by the dominance of halophilic microorganisms, particularly the algae, Dunaliella salina, and halophilic bacteria such as Halobacterium. These organisms are able to survive and thrive in waters with high salt concentrations. Dunaliella salina produces carotenoid pigments, especially but as a cellular protection mechanism against high solar radiation and osmotic stress resulting from extreme salinity. The accumulation of these pigments gives the lake water its pink to reddish coloration. From the standpoint of aquatic chemistry, Lake Hurrell has a relatively high salt concentration compared to typical freshwater lakes. This high salinity may be caused by evaporation rates that exceed water input, minimal outflow, and climatic conditions that tend to be dry and hot. As water evaporates. Salts and minerals remain behind and become increasingly concentrated, creating an ideal environment for pigment-producing microorganisms. Physically, the intensity of Lake Hurl's pink color can vary depending on the season, temperature, and the angle of incoming sunlight. During the dry season, when water volume decreases and salinity increases, populations of halophilic algae and bacteria tend to grow, making the pink color appear more vivid and intense. Conversely, during the rainy season, the influx of fresh water can reduce salinity and dilute pigment concentrations, causing the lake's color to appear paler. The pink color phenomenon of Lake Haro also reflects a unique yet sensitive ecosystem. Small changes in the chemical balance of the water, such as the introduction of pollutants or alterations in surrounding land use, can disrupt the populations of microorganisms responsible for the coloration. Therefore, the pink color of Lake Haro can serve as a natural biological indicator of environmental change and water quality. In conclusion, the pink color of Lake Haro is the result of complex natural processes involving high salinity, the presence of pigment-producing halophilic microorganisms, and local climatic and hydrological conditions. This phenomenon makes Lake Haro not only visually striking, but also scientifically significant as an object of study for extreme aquatic ecosystems.